page. I don't think that we filled in anything in the box. Is that correct at the bottom? Okay. We haven't talked about this in a while, but let's see if we remember. If I have a linear, and I solve a linear function for x, how many answers do I usually get?
3.
1. A linear, I get 1. When I solve a quadratic, how many answers do I usually get? 2. So if I had a... Maybe we need to refresh. Okay, let's start with linear function. Linear function is a line. So how many times can it cross the x-axis?
1.
Okay, so that means an answer that you get 1 answer because there's 1 x-intercept. With a quadratic, usually when we graph it, how many places does it cross the x-axis? 2. Twice. Okay? So a linear has 1 answer, a quadratic has 2. If I were to graph a cubic, which we will eventually, how many answers do you think that would have?
3.
3. And if I had a quartic, it would have 4. And it just keeps going up from there. Okay? So the fundamental theorem of algebra basically says that the number of solutions, x-intercepts, matches the degree. Now, we haven't really, maybe we have talked about the degree, but matches the degree. The degree is just a way to say the highest exponent. So a linear has 1 answer, a quadratic has 2 answers, okay, etc. This fact, or this, the fundamental theorem, if you were to look up the fundamental theorem of of algebra, it would be really wordy, use lots of math terms, but essentially this is what it means. So this is what we've talked about. And I've brought it up several times so that this isn't brand new when we get to it. Alright? We need to know this fact in order to do problems on the next page. We got that written down? Okay. The type 4 for this standard works with that fundamental theorem. So I'll say, write an equation, and now I'm not going to tell you what of. So I'm not going to tell you if it's a linear, a quadratic, or something else. I'll just say write an equation of a polynomial. Now, polynomial, poly means many, nomial means terms. So this could refer to a linear, because that has 2 terms. This could refer to a quadratic, because that usually has how many terms? 3, an x squared, an x, and then a constant. It could refer to a cubic, because that has 4 terms, a cube term, an x squared, an x, and then a constant. So I'm not telling you which one it is. We're going to determine that at the end. So write an equation of a polynomial given its x-intercepts are 3, -2, and 5. Okay? So how many x-intercepts did I give you? 3. So at the end we should have what type of function?
Cubic.
A cubic. Okay. Now how do we work backwards? Because if I was to give you x-intercepts for a quadratic, we could do something with that.
Can we plug them in for x?
We're going to do something like that.
Oh, wait. No.
We're going to work with the setup, kind of like when we have x-intercepts, since I'm giving you x-intercepts. for quadratic. When we had quadratic with x-intercepts, we worked with the form. You don't have to write this down. I'm just trying to find a blank place to write it. Whoa. That. Okay, so we've done an example today when we had x-intercepts and I told you to write a quadratic, we used this form. So we had parentheses, and then inside both those parentheses we had x minus something, x minus something. We're going to work with that same setup here, except at this point I'm not going to give you enough information to find your a. So we're just going to work with the x-intercepts that are given to us. I would need 3 parentheses because I have 3 x-intercepts. I would need to have an x, an x, and an x. And in order to get 3 as an answer, because my x-intercepts are my answers, I would have to have x what? X minus 3. Because I would have to take this parenthesis, set it equal to 0, and get 3 as an answer. If I set x minus 3 equal to 0, would I get 3 as an answer? Yeah. So that's what we're going to have here. What would I have to get to have negative 2 as an answer? 2 plus 2. 2 plus 2. And in order to get 5 as an answer, what would I have to have? Negative 5. Negative 5. Okay. So we have x plus 2 and x minus 5. Now, this technically could be your answer, but I'm also going to have us practice with this standard, simplifying it so it actually looks like a cubic and not just separated out with parentheses. So we're going to multiply some stuff together. We do, but we're going to do it a little bit at a time. We're going to do a table method because I know you guys have talked about that in Algebra 1. We're going to review it here. My suggestion is to start by multiplying its first 2 parentheses together. So focus on multiplying those together first, so I can use FOIL there. If I use FOIL there, I get x squared. My outer terms are 2x. My inner terms are negative 3. So 2x plus a negative 3 gets me what? Negative x. And the negative 3 times 2 gets me negative 6. Now, we cannot use FOIL here because now we have 3 terms times 2 terms. There were 3 different ways I think you learned how to do this in Algebra 1, and you got to pick the way that you liked. You can set it up as a multiplication table, which is the way I'm going to use here. You can also just distribute. So you could distribute x squared through both, write down what you get. Then you'd have to take negative x, distribute it, and negative 6, and distribute it. Either way you do it, you're going to get the same answer. But I tend to find that most students like the table method, where you take one of these polynomials and you write it across the top. It doesn't matter which one. And the other polynomial you write down the side. Does this look familiar?
No. Yeah, kind of.
Kind of? Okay. Well, if it does or doesn't, this is a pretty fast way to multiply it out. And visually it's nice because it kind of looks like a multiplication table. And when you fill out a multiplication table, you take the row and the column and multiply them together to get your missing piece here. So x squared times x gets me what?
2x.
How many x's is that?
3.
3. So we write it as an x cubed. Good. Negative x times x gets me negative x squared. Good. And negative 6 times x, negative 6x. Negative 5 times x squared. Yes, there I would get negative 5x squared, so that fills in this missing piece. Negative 5 times negative x gets me 5x. And to fill out this last box here, negative 6 times negative 5 gets me 30. Now, when you use the table method, do you remember where you're, like what do you draw in next? do the diagonals. Good. So we usually group them like this. The diagonals end up being your like terms. And when you write your final answer, it'll be y equals x cubed, and then negative 1x squared plus a negative 5x squared gets me negative 6x squared. Negative 6x plus negative 5x gets me negative x, and then the last term would be 30. Okay? So this is the table method. If you like that method, you can use that method to multiply together that trinomial, because there's 3 terms, binomial. But your answer should have no parentheses in it, because you should multiply it out completely to get your cubic.
That's for all of them?
For all of them, yep. Now, the other type, because you'll notice that each one of the answers here was just a number, didn't have any imaginaries in it. But sometimes your answers to questions have been imaginaries. So some of your quiz answers were imaginary answers. So what happens if the answers that I give you have imaginary numbers in it? Well, you could set it up the same way, like we did here with 3 parentheses. However, when you start multiplying stuff together, it starts to get really messy. You're still able to do it that way, but there is a little trick to multiplying complex roots or answers that have imaginaries in them. So I'm going to show you that right now too, because there's a pattern that happens every time. So the pattern of complex roots within a polynomial, and maybe before we actually write these steps out, I'll give you the example so that you can see an example that would use this pattern first. So the example would be written the same way. Write an equation of a polynomial given x-intercepts of negative 1 and 2 plus or minus 3i. Now, I will tell you that complex answers or answers that have imaginary numbers in them always come in pairs. They always come in pairs. So if 2 plus 3i is an answer, automatically 2 minus 3i is an answer every single time. And I'll say that again so that kind of gets into your brain. The pattern that happens when you have complex answers, because, and I'm going to write it out in a different piece of paper here. If we set it up, don't write this down, just watch. If we set this up the same way, the negative 1 would look like that as an answer. But then 2 plus 3i, you'd have to write x minus 2 plus 3i, like that. And then x minus 2 minus 3i, like that. Does that look yucky to multiply together?
Yeah.
Yes. So I don't want you to set it up the same way when you have complex answers. I want you to use this little shortcut. Because you could set it up this way and figure it out. However, it's going to look messy and it's going to be a lot of work, where this little trick avoids some of that. All right, so when you have complex answers, the pattern that happens is you're going to find the sum of your complex roots and the product. What does sum mean? Adding together. What does product mean? Multiplying together. You've done that before. That's what standard S1 is all about, is adding and multiplying complex numbers. The pattern is x squared minus your sum x plus your product. So if you were to FOIL together those messy looking parentheses that we had on the other page, it would always end up, after lots of work, coming to this pattern here. That whatever the sum of the complex numbers are, they get put in that spot. And then whatever the product is, they get put in that spot. Because isn't that what you always do? Is when you FOIL together, these two numbers multiplied together go last, and the outer and the inner add together to get the middle term. Isn't that what happens every time? Yeah. So instead of doing it with x's, we do the sum and the product separately and then just put it into the pattern. So this is the same pattern that we've been looking at every single time. It's just we do the work separate and then put them into the parentheses. So I'm going to start finding my polynomial by taking care of that -1, because that doesn't have an imaginary, so that would be the same setup as I had before. But before I write in my parentheses for this complex number stuff, I'm going to do that work off on the side. So you find your sum and your product, and I just label that S and P. So my sum, I'm going to take 2 plus 3i and add 2 minus 3i. My two complex answers there. What happens when I add those together?
0.
Not quite 0, but it's going to be 4. But what does cancel out? Yeah. The i's cancel, leaving you with 4. And if I multiply them together, we've done this before. You FOIL them together. 2 times 2 gives me 4. My outer, -6i. My inner is +6i. So -6i plus 6i gives me 0. So the i's cancel. And then my last terms, 3i times -3i gives me -9i squared. But what does I squared equal? Yeah, I squared is -1. Some of you are jumping ahead. I squared is -1. -1 times -9 is 9. 9 plus 4 is 13. So your product will end up being 13. Okay. Then you take your sum and your product, and you're going to put it back into this pattern here. So x squared minus the sum x plus the product. Okay, so basically by doing this and putting it into the same pattern that every FOIL stuff works into, you avoided all the messy foiling of the parentheses. Because it would always simplify down to get this. Okay, now instead of doing the table method here, you can do the table method if you want, but instead of doing that here for this one, I'm going to review how to do it the horizontal method, which is just distributing through. Because to finish this out, we're going to actually multiply these together. So x times x squared gives me x cubed. X times -4x gives me -4x squared. X times 13 gives me 13x. So I'm just distributing this through. And then I'm going to distribute 1 through. So 1 times x squared gives me x squared. 1 times -4 gives me -4x. 1 times 13 gives me 13. Okay, now what is my final step here? Add up the like terms. So y equals x cubed. -4x squared plus x squared gives me -3. 13x plus -4x gives me positive 9x. And my last term is 13. Okay. Now I know this is the first time that we've done these types of problems. We will be reviewing this more heavily on Monday. And if you get to W1 practice today, you might have to do some of this. But if you don't, we'll spend Monday working on it too. But at least now your notes are finished. Okay. I need you to go to iTunes U. I'm going to get you up and moving around a little bit. Go to iTunes U and download the speed dating practice for today, if you would.